Hello everyone, welcome back to the playlist of numerical methods. In the previous videos, we have understood what is Gauss Integration Method and we have also done some questions based on it. In this video, we will try to code the same method in MATLAB. Before starting the MATLAB code, let us revisit the method here. The Gauss formula for n is equals to 2 is f of minus 1 by root 3 plus f of 1 by root 3, and Gauss formula for n is equals to 3 is displayed here. We also know that Gauss formula imposes a restriction that limit should be between minus 1 and 1 only. Whenever we are given the limits from a to b, we always change these limits with the help of the given transformation. So, to code this formula, the first thing that we need is the function. Secondly, we need to define the integration interval. After that, we will check if the limits are minus 1 and 1 or not. If not, then we have to firstly convert our function using the transformation and then apply the formula. We will try to code the formula with the help of this example, and we can see that the limit here is from 0 to 2, not from minus 1 to 1. Let us quickly starting the MATLAB code. Saving the function value in f using input function, and here we have been trying to integrate the function x square plus 2x plus 1 divided by 1 plus x to the power 4. So we will enter the form as x dot cap 2. Make sure that you are using dot because we will be using point-wise operation here, plus 2 into x plus 1, this whole divided by 1 plus x to the power 4. After that, we will define the integration intervals. Firstly, taking the value of lower limit in variable a and the value of upper limit in variable b. In this question, the lower limit is given as 0 and the upper limit is given as 2. After that, we will check if the limits are minus 1 to 1, and if not, then we use the transformation. For that, we will use if condition. The value of a is not equals to minus 1 and the value of b is not equals to 1. Then we have to replace the x value by 0.5 into b minus a into u plus 0.5 into b plus a. So basically, we have entered a function f of x and we will transform it into the variable u by replacing x as alpha times u plus beta, where the value of alpha is 0.5 into b minus a and the value of beta is 0.5 into b plus a. Since in this question we are trying to find the integration of f of x from a to b, there is variable x, so it will be integrated with respect to x, while we have transformed it into the form of minus 1 to 1 f of alpha times u plus beta. This term will be integrated with respect to the variable du. And how will we find the variable du? By taking derivative on both sides of this equation, that is dx is equals to alpha times du, where the value alpha is 0.5 into b minus a. I hope you have understood what we are trying to do here. So the statement of line will be f of u is equals to function with respect to u of f, where the x value will be replaced as 0.5 into b minus a into u plus 0.5 into b plus a. This is for this term, but when we will integrate, the extra term du is also being multiplied here, so we will multiply this whole term with 0.5 into b minus a. Else we will update function f underscore u as f only, and this if condition will end. After that, we need to know the number of Gauss points, and we have derived the formula for the value of n is equals to 2 and n is equals to 3 only. So we will code this for the values of n is equals to 2 and 3 only. Taking the user input, and then initializing the Gauss points and weights for different values of n. If the entered value of n is 2, in that case the Gauss points are minus 1 by root 3 and 1 by root 3. Numerically, we can write it as 0.577350. And the corresponding weight points are 1 and 1 only. You can also skip the comma here and replace it with the space. Else if the value of n is entered as 3, then the corresponding Gauss points are minus 0.774596, 0 and the 0.774596. The corresponding weight points are, else if any other value of n have been entered, it will generate an error by saying, and this if condition will end. Then we evaluate the transformed function f of u at the Gauss points using f underscore mapping variable to store the evaluated points at Gauss points of function f underscore u. Then we apply the Gauss integration formula using the variable I to store sum of weight points into the evaluated Gauss points at f underscore u. And then finally we will display the results. I hope I have made this code clear to you, and this was quite simple code. And if you want the manual solution of this question to make an understanding of this code in a better way, do check out the video I have posted over the practice questions based on this method, and its link have been provided in the description box. If you still found any doubt in this code or you are not able to understand any line of code, then do let me know in the comment sections. And here are some practice questions for you all. Firstly, try to solve these questions manually and then try to implement them on the MATLAB using the code I have provided you. I hope my efforts are helping you to understand these methods in a better way. If you have found this video useful, don't forget to share it with your friends. Happy learning!